negative 2. 4 to the right and 2 down. So I have 2 points, any 2. I just happen to have chosen 2 points which are very close together to make it easy, okay? But they could be very far apart. And those could represent locations, right? Distances to locations, okay? And there's a certain distance between them. Hopefully we would agree that the shortest distance between any 2 points is a straight line, right? Of course we could go down here instead and over, but that's not the fastest way to get somewhere, okay? So whenever someone asks you in a math class to find the distance between 2 points or the length of a line segment, same thing, right? What they're really saying is find the shortest way from point A to point B, the shortest path. Well, one way that we could do that is by just memorizing a formula, and I'm going to give you the formula in a second, but I want you to understand where it comes from if you've never thought about it. When I first learned this, I was not taught where anything came from, and so I just memorized it and didn't like it very much. And then I had a professor who explained everything, why it worked, and I was so excited. So I hope that will help you a little bit. Maybe you don't care, that's okay. All right, so when I'm talking about the distance between these 2 points, where the formula comes from, which we'll describe in just a moment, is this idea. I could have alternately gone down 1, 2, 3 units, couldn't I? And then turned to the right and gone 1, 2, 3 units. And I'd get there, wouldn't I? So I went down 3, it's kind of like that rise and run idea.
Yeah.
Down 3, over 3. Or I could have gone up 3, over 3. Either way, right? And I'd still get there. Apologize for my bad line segment. Okay, there it is. In either case, you'll get a right triangle, don't you? 90-degree angle. Okay. And what we're supposed to always remember is a fact in nature. And this fact of nature was discovered by the Greek man Pythagoras. And that was discovered to be that anytime you have a truly right angle here in a triangle, it doesn't matter what we call this side or this side. Usually we say A and B. But the one that matters is this one, the long side, the hypotenuse. We call that C. Anytime you have this relationship in a right triangle, a squared plus b squared will always equal c squared. That's called the Pythagorean theorem. You've heard it before, I'm sure. Okay? And so with that in mind, we can solve for that red distance, can't we? Because that's just c, isn't it? So what would this mean here? In our case, a is how many units? 1, 2, 3. And b is also 1, 2, 3, just by counting. So according to the Pythagorean theorem here, we would have 3 squared plus 3 squared equals c squared, wouldn't we? But 3 squared is really 9. So 9 plus 9 must equal c squared. But 9 plus 9 is really 18, so 18 must equal c squared. Now last class, we reminded ourselves what to do in this case. We had problems where we were solving quadratic equations last class, and we had something squared equals a number. What did we do to get rid of the square? Square root. So similarly, we normally would have said plus or minus the square root of 18 is equal to c, right? But because c is a distance, we don't need the plus or minus because distance is always positive. We're not talking going backwards, okay? So what we have here is that our distance here is the hypotenuse of that right triangle. It is the square root of 18, which is a little more than the square root of 16. The square root of 16 is 4, right? So this is a little bit bigger than 4. You can put it in your calculator right now. What is the square root of 18? Go ahead and type it in. Approximately, what does C give you? 4 point something, right? Square root of 18? Yeah. 426. Okay, so we'll say 24. Thanks. Yeah. So this would be called the approximate answer, which is more helpful to most of us in real life. Maybe these are locations, and this is how many miles apart we are. 4.24 miles. Okay. The shortest distance. The exact answer, however, would be the radical, the one with the radical. And so what we would expect you to do is be able to simplify this radical in a math class. So if you don't remember how to simplify radicals, you might need to go to the Math Center or check out Khan Academy. But to simplify this radical, remember, the square root of 18 is really the square root of 2 times 9, right? And 9 is really a pair of threes. Now, as soon as you have 2 of a kind, because it's a square root, you need 2 of a kind, don't you? That's going to be 3 coming out, but the 2 is trapped because he didn't have a partner. So 3 square root of 2 would be the exact answer that they would want in my math lab. Okay, so you have to be able to simplify radicals. If you don't, make sure you look that up or get someone to help you with that so you feel more comfortable. All right, so we just reviewed quickly how to find the distance between 2 points by drawing a right triangle, didn't we? And then using the Pythagorean theorem. But a faster way to do this, in case the points are very far apart and you don't want to sit there and count up how many A is and how many B is, right? Is to use the formula. So here's where the formula comes from. The distance formula between 2 points comes from this idea of using the Pythagorean theorem. And remember what we ended up doing. We ended up getting c squared, but then we had to take the square root to get c. So to get that distance, which was c in the triangle, we took a square root of something, didn't we? We didn't just take a square root of something, we took a square root of a squared plus b squared, didn't we? So something plus something. So a was squared and b was squared. But how do you get a and b if you didn't count them up? Like here I just counted 1, 2, 3, 1, 2, 3. You use the points, don't you? And what would I do with those? Would I add them? Would I subtract them? Would I multiply them?
Subtract.
I would subtract them. The basic idea is, if remember on the interstate, like in Florida, we have I-75 where we drive, right? If someone says that they are starting their trip at mile marker 100 and ending their trip at mile marker 250, do we know how many miles that they went without counting up every mile? Yeah, we subtract, don't we? 250 minus 100. Similarly, if we know that we started at the x value of 1 and ended at the x value of 4, don't we know how many x values we moved? 4 minus 1, right? In other words, to get a, the horizontal distance, you subtracted your x values. So you took x2 minus x1. That's how you got your a. Similarly, to get the distance that you traveled in the vertical direction, we'd subtract our y values. y2 minus y1. So this is the formula, but now I hope you understand where it comes from. It comes from the Pythagorean theorem.